several work and research has been put into exploring certain phenomena in space and the possibilities of colonizing our neighboring planets. Tesla and SpaceX CEO Elon Musk has developed quite an attraction with the idea of putting humans on another planet, and he has been working intently to achieve this dream. Aside from Mars, he has also looked into other planets with his subsequent focus on Venus. As a result, several probes were sent to examine the planet with partnership from the Soviet Union, and Elon Musk just leaked what one of the probes found on Venus. What did the Soviet probe see? Could life be thriving on a planet that we didn't know? Join us as we explore why Elon Musk leaked what the Soviet probe found on Venus. Named after the Roman goddess of love and beauty, Venus is now the center of focus for many scientists and researchers. This planet was named Venus because it was the brightest among the 5 planets known to ancient astronomers. In fact, it was once called Aphrodite by ancient Greeks. In those times, Venus was initially believed to be the morning and evening stars, that is, the one that first appeared at sunset and sunrise. These stars were respectively known as Vesper and Lucifer, but that changed with the new technological tools scientists working under Elon Musk came up with. Venus is a little smaller than Earth, but similar to Earth in size. Venus's surface cannot be seen clearly due to its thick clouds, but Elon Musk, being the genius he is, collaborated with the Soviet Union to send Soviet probes up to the planet. Before Elon Musk's partnership, the Soviet Union had been making efforts to explore Venus. So at the beginning of the space age, they designed and constructed several spacecraft to explore the Venusian atmosphere. This program was called the Venera program. Launched between 1961 and 1983, the Venera missions conducted by the Soviet Union were done to explore Venus. But of all the 26 spacecraft launched, 13 entered the Venusian atmosphere and 8 successfully touched down on the surface, despite some failed attempts. The first probe to successfully land on Venus and send data back on its surface was Venera 7. With its landing in December 1970, Venera 7 was built to enter the planet's atmosphere before deploying a parachute to help reduce its descent toward the surface. But unfortunately, the parachute ripped and failed during the descent, leaving Venera 7 falling freely at immense speed for 29 minutes before landing on the Venusian surface with a hard thud. As scientists monitored the Soviet Union probe, it appeared to stop sending signals. But when scientists later analyzed the recorded radio signals, it turned out that the probe survived the fall and continued transmitting a poor signal for another 23 minutes. Scientists believe that the reason for the weak signal is that the spacecraft could have dropped onto its side upon landing, so the antenna stopped pointing toward the Earth. Regardless of its situation, the lander measured a surface temperature of almost 90 degrees Fahrenheit, or in simpler terms, about as hot as a brick pizza oven. Also, as the spacecraft fell to the Venusian surface, its pressure sensor failed, and that left researchers with an estimated surface pressure of about 92 bars, a pressure you would only be able to feel on Earth if you were submerged into half a mile of water. The Soviet Union didn't give up on exploring Venus, though, as they came up with Venera 9 and Venera 10. 9 and 10 landed on the Venusian surface 5 years later and took a 180-degree panorama of the planet's surface. This artistic view you're looking at was created by Ted Strick, who used the images in the panorama taken by the lander to show what the planet would look like if an astronaut was standing on Venus's surface. The view was created by changing individual images in the panorama to present the surface at a more natural angle, therefore sampling each image at different distances from the lander and using image data to fill in any gap remaining after this process. The objects in the image are natural, but the arrangement isn't. However, to see more features of this planet, the Soviet Union went on to create more space probes, and the Venera 14 provided just what they wanted. The Venera 14 Soviet lander parachuted and air-braked down through the thick Venusian atmosphere in March 1982. It also took a picture of its environment. The empty area it pictured showed flat rocks, a featureless sky near Phoebe Regio near Venus's equator, and sizable empty terrain. On the lower left, the spacecraft's penetrometer is visible as it makes scientific measurements, while the light piece on the right is part of an ejected lens cap. After coping with a temperature of 450 degrees Celsius and pressures 75 times Earth's, the solid Venera spacecraft operated for almost 1 hour. Although data from the Venera 14 spacecraft was sent across the inner solar system almost 40 years ago, the spacecraft's images and digital process are still done today. And a recent analysis of infrared measurements taken by ESA's orbiting Venus Express spacecraft shows that active volcanoes may currently exist on the planet. These theories about volcanoes being on the planet turned out to be accurate, as Elon Musk and the Soviet Union kept pushing with their mission. Research and tests on the Venusian atmosphere depicted Venus as the planet with the most volcanoes in the entire solar system. Over 1,600 significant volcanoes have been detected across the planet, and there are still thousands more that have not been found yet. A major part of the planet is covered in volcanic deposits close to about 200 million years old, and this volcanic activity has played a crucial role in the planet's history. Scientists are still debating if there are still active volcanoes for many reasons, but due to the planet's thick atmosphere, scientists had to turn to the radar that NASA's Magellan spacecraft obtained. In their quest to discover more about the volcanic deposits, the Soviet Union scientists devised a new methodology that could help solve the mysteries of volcanic activity on Venus. The approach comprises geologic mappings of cooled lava flows from the former eruptions with additional radar data from the Magellan mission. It relies on the measurements of the planet's radar emissivity, which measures how its surface interacts with and emits microwave radiation. Several parts of Venus's surface have shown different types of emittance that match different rocks' properties, giving hints about their formation. Also, recent research has suggested that radar emissivity can also be used to figure out the degree of chemical weathering experienced by lava flows after they erupt and come in contact with the Venusian atmosphere. Such weathering happens over weeks or months, so emissivity could help identify fresh lava flows. The Soviet Union researchers combined the radar emittance measurement with geologic mapping to compare 3 Venusian volcanoes, Mart Mons, Ozar Mons, and Sapis Mons. These findings show that some lava flows at Mat Mons might be relatively young. Moving forward, the same approach could apply to additional Magellan data to examine Venus's volcanoes further. The methodology could also be necessary for future Venus missions that will supply higher resolution radar emissivity measurements, including the European Space Agency's On-Vision mission and NASA's Venus Emissivity, Radioscience, INSAR Topography, and Spectroscopy mission. However, more research was conducted under the supervision of Elon Musk with this methodology. Scientists and researchers analyzed Idun Mons, a Venusian volcanic peak about 2.5 kilometers high and 200 kilometers wide. It is located in Imda Regio, a volcano-rich highlands region in southern Venus. In the research, the outcome looks like there's a recent activity from the volcano. Earlier research has shown that the planet has fewer craters from cosmic impacts than one would expect, judging from the number of craters that are noticed on other rocky planets in the solar system. From what the scientists deduced with the Soviet Union probe, their findings suggests that the lava from these active volcanoes may be a factor that keeps Venus's surface clean. A better understanding of volcanic activity on Venus could help shed more light on the recent detection of phosphine gas there, which some researchers have bizarrely suggested may be linked with life on the hellish planet. The possible phosphine in Venus's atmosphere could be related to a recent volcanic occurrence or one that is going on presently on the planet. This is why finding sites of potentially active volcanic material on Venus is crucial. In 2010, the European Space Agency's Venus Express spacecraft was on a mission in collaboration with Elon Musk and the former Soviet Union. On this mission, the team searched for infrared irregularities on the top and eastern parts of Idun Mons. Discovering this anomaly suggested the presence of fresh volcanic deposits on the planet. It also postulated that the area had experienced active volcanism in the past million years. Having detected this, scientists processed spacecraft observations of the peak for any signs of recent activity. They gathered this data along with lab studies on how volcanic rock changes when exposed to temperatures with high surfaces and the corrosive, sulfurous, carbon dioxide-rich Venusian atmosphere. Scientists then analyzed surface images of the Venusian planet captured by Venus Express and NASA's Magellan spacecraft, and they confirmed the presence of recent lava flows at Idun Mons. When the scientists analyzed the atmospheric data from Venus Express, they found out that the winds are slower than expected in the lower atmosphere over IMDA region. Soviet Union researchers proposed that this occurrence could be due to heat from recent or ongoing lava flows. The researchers also discovered surface fractures which they suggested were traces of tectonic activity happening together with volcanic activity. Tectonic activity, which many considered a bizarre anomaly, sounded like good news for Elon Musk. How is a planet like Venus, which scientists confirmed to not have tectonic plates, exhibiting tectonic activity, a process that defines Earth's geology? Elon Musk's mission in collaboration with the ESA's Venus Express has proved scientists wrong by detecting several tectonic structures. From a planet that had no tectonic plates to one that suddenly had several, it became a mystery to know how and when those structures were formed. And this is crucial because figuring out this phenomenon happening on Venus is essential to understanding the process that probably took place in Earth's early history and the evolution of other rocky planets. Venus is a planet that has long been perceived to be geologically dead for millions of years. But as active volcanoes were recently detected on the planet, it has brought new questions to the debate about Venus's surprising geology. These prominent ring-shaped features on the surface of Venus with traces of tectonic and volcanic activity also stand as evidence of an ongoing change in Venus. Coronas are large ring-shaped features on the surface of Venus with proof of tectonic and volcanic activity. They are characterized by unique shapes with huge dimensions spanning from 60 to over 1,000 kilometers wide. Coronas are different from any volcano we observe here on Earth. These large ring-shaped coronas have formed where rising hot magma from the planet's depth makes its way up through its mantle and crust. As a result of its composition, the rising hot material might destroy patches of the planet's surface and form peculiar corona structures. Scientists had initially believed that coronae were ancient structures spanning tens and hundreds of millions of years. However, coronae shows a massive array of shapes and structures, and the motive behind this diversity remains unexplainable. The Soviet Union scientists didn't want to give up, however, so they ran a couple of simulations. These simulations showed that a corona's shape depends on the thickness and strength of the crust where the magma hits it. Overall, the simulations also show that these shapes are directly related to how active the column of magma beneath the surface is. When the computer models the shape of a corona changes fast as time goes by, as the hot, rising magma slowly cools down and solidifies. Due to this, the researchers discovered telltale signs showing whether a region is geologically active. They knew through signs where deep trenches and outer rises show activity, while a raised rim with an inner depression depicts inactivity. With the outcome of these situations, over 100 large coronae on Venus were classified into two groups: those that have formed above an active region of magma that is currently rising and carrying molten material, while those above a region that has already cooled down and become inactive. This assessment was done by examining the coronae shapes using topography data obtained from NASA's Magellan mission in collaboration with Elon Musk. This assessment showed several ongoing magma activities on the planet, as most were located in a belt in Venus's southern hemisphere. The results also serve as new leads for widespread recent geological activity on the surface of Venus. But what about craters on the planet? There are craters on Venus as well, but not much. The solar system is almost empty now, but less than 1 billion years ago, there were still many objects moving around after the solar system's formation. These objects crashed into the planets and moons, and it happened over a while, which scientists refer to as the late period of heavy bombardment. During that period, many of the craters on Mercury and the Moon were formed. Surprisingly, Venus does not show any record of the heavy bombardment period. Maybe it wasn't hit, which is a slim chance, or it could be that some process resurfaced the planet, removing all traces of the impact craters. The resurfacing process stopped at a specific time in Venus's more recent history, which makes scientists believe that the craters in sight on the surface of Venus are relatively young. Craters on Venus are exceptional from other craters on other planets. Venus's thick atmosphere prevents the smaller objects from getting to the planet's surface because they would have burnt up in the hostile atmosphere. There are about 1,000 craters noticed on Venus's surface. The crater Meade is the largest of them all. Named after the American anthropologist Margaret Meade, the crater measures 280 kilometers in diameter and contains several concentric rings. There could have been bigger ones, but scientists are yet to confirm if the planet wasn't hit by the bombardment or has a process that refines the planet's surface. With the detection of geological activity like corona on the planet's surface, the next question would be to ask if Venus has life forms. A team of astronomers reported a recent incident concerning this question and stated that the discovery of life forms on Venus occurred when they found traces of Venusian microbes. They tried to observe these traces with the use of powerful telescopes, and that was where they discovered a chemical in the thick Venusian atmosphere known as phosphine. "We know that it's an extraordinary discovery," stated Clara Souza Silva, a molecular astrophysicist at Harvard University whose research is focused on phosphine. "We may not know just how extraordinary without going back to Venus," she concluded. Even Sarah Stewart Johnson, a planetary scientist and head of the Johnson Biosignatures Lab at Georgetown University, who was not involved in the work, said, "There's been a lot of buzz about phosphine as a biosignature gas for exoplanets recently, referring to the search for life on worlds that orbit other stars. How cool to find it on Venus." As a result of the phosphine gas discovery, a privately funded mission was created to observe the Venusian atmosphere. The mission aims to detect if there is actual phosphine on the planet and to see if it can be habitable, courtesy of Elon Musk. Despite being a privately funded mission, it wasn't only Musk who was handling this project. Alongside the tech billionaire, the mission is also led by researchers from the Massachusetts Institute of Technology. The Breakthrough Foundation, in collaboration with the Elon Musk Foundation and SpaceX, sponsors it. The principal investigators behind the project are Jewish-American scientists Sarah Seeger and Elon Musk. Named the Venus Life Finder missions, the series of projects would be based on a probe sent to Venus to discover if the planet has life forms. This brainstorming started in September 2020 when a team of scientists, including Seeger, found phosphine gas in the Venusian atmosphere. This form of gas is not life because it is just gas. However, phosphine is produced by anaerobic bacteria living in oxygen-starved environments. Making this discovery was a joy to some as it proved that life, although bacterial life, existed on another planet. But how is it possible with the planet's scorching heat and overall unfavorable conditions? We all know that Venus's surface is not habitable, but the cloud deck located about 50 kilometers above the surface is. It is similar to Earth's lower atmosphere and could theoretically support some microbial life. However, there is still some disbelief in the theory, as rechecking the data caused some scientists to propose that the theory was misinterpreted and that the molecules could be sulfur dioxide, a gas that is very common in the clouds of Venus. In science, researchers need to be sure about a particular phenomenon before acting on it, so sending a probe to collect samples from the cloud deck was required. The mission cannot be done on an interstellar scale, but in Venus's case, which is closer to Earth, the mission looks more promising. Their first mission is arranged to kick off in 2023 on an Electron rocket which the California-based Rocket Lab would make in collaboration with Elon Musk's private space agency. This rocket would be the launch to greatness, as it would send the probe on a 5-month trip for just 3 minutes through the clouds. To attain the best results, the probe would come equipped with a specially designed laser instrument to find complex chemistry in the clouds. And if such impurities or fluorescence are detected, then it's a sign that there's more to the Venusian atmosphere than we know of. Scientists have already developed general theories about Venus's clouds, atmosphere, and anomalies regarding the chemicals and elements present. Even some particles of unknown composition are included. However, if there's any form of life on Venus, it has to be microbial, as the clouds are the only habitable part of the entire planet compared to other parts. Despite the clouds being the only haven on the planet, some challenges are likely to be faced on the mission to Venus and when taking samples. One such challenge during observation of the clouds is the absolute concentration of sulfuric acid, which is hundreds of times that of Earth. And if these challenges are right there, what are the chances for the Venusian clouds to inhabit life forms, and how does it host life? Seeger has mapped out some answers for us. To begin with, these bacteria could bring about ammonia to suppress sulfuric acid. However, it is still very possible that life could exist in a way completely strange to us, with a form of biochemistry that supports sulfuric acid. Also, this is something that other scientists have put into thought. What defines life? Nobody knows, stated Pete Warden, executive director of the Breakthrough Initiatives, a program established by Russian-Israeli billionaire Yuri Milner that has helped fund Seeger's research. The discoveries of the 2023 missions could shed light into different places on the many mysteries of the Venusian atmosphere. Regardless of what the space probe would find on the mission, plans are already underway for a follow-up mission in 2026. By then, a larger probe could be sent to Venus and equipped to remain in the clouds for a more extended period of time to gather data. Still, all of these efforts will add to the ultimate peak of the project, bringing back a sample of the Venus atmosphere. And even if all of these endeavors turn out disruptive and futile, it still helps scientists and researchers to find out more details about the planets around us. What do you think about the mission to examine Venus's atmosphere? Let us know your thoughts in the comments section below.